Anyone paying close attention to the artificial intelligence space lately has felt it. The fireworks show is slowing down. We remember the jump from GPT-2 to GPT-3. It was a jaw-dropping leap that changed the world overnight. But looking at the current landscape with GPT-4, Claude 3 Opus, and Gemini 1.5, the feeling is different. They are undeniably strong, but they don't represent that same exponential explosion we got used to. Benchmarks keep climbing, sure, but the real-world wow factor isn't doubling every 6 months anymore. This slowdown isn't imaginary. It is cold, hard economics. We have hit the performance wall. Training a frontier model now costs hundreds of millions of dollars in compute and data curation. To get just one extra percentage point on a leaderboard now demands exponentially more GP2s and more tokens. We are seeing diminishing returns everywhere. Even with massive context windows of 1 million tokens, the models still fail to reason effectively over that data in brittle, unpredictable ways. So, if the raw power of the models is plateauing, does that mean the AI revolution is over? Absolutely not. The frontier has simply shifted. The innovation is no longer happening inside the model weights. It's happening in the layer around them. We are moving from the era of faster CPUs to the era of better operating systems. This is the rise of the agent harness. Think of a raw LLM call like a bare silicon chip or a stateless API hit. You send a prompt, you cross your fingers, and you hope the model understands your intent. It might ignore tools, forget previous steps, or hallucinate APIs that never existed. It's impressive on paper, but fragile in practice. But drop that same model into a harness, and the behavior changes completely. The harness turns a clever autocomplete engine into a dependable coworker. The real revolution is the wrapper. Projects like Anthropic's internal frameworks and LangChain's Deep Agent are proving that the value capture is moving from the lab's training runs to the engineer's harness code. A modern harness is essentially an operating system for models. It handles control flow, memory persistence, and tool use, so an LLM can survive outside a demo environment and actually function inside a production SLA. Without this layer, prompt-only systems behave like interns with amnesia. Ask a raw LLM to refactor a 200,000-line code monolith, and you will get partial edits and broken imports. But a harness-driven agent? It can scan the repo, chunk files, refactor module by module, run tests, detect failures, and roll back changes. It creates a loop of planning, acting, observing, and revising. Let's decode the anatomy of a production-grade harness. It is not just a glorified while loop, it is a state machine. It forces the AI to transition between specific states, like planning, tool call pending, or awaiting human input. This structure makes behavior reproducible and debuggable, replacing vibes and hope with concrete engineering logic. At the base of this anatomy sits the state manager. This module tracks the agent's current goal, its history, and execution metadata. In systems like Deep Agent, this is a structured object that flows through every call, giving the model a canonical view of where we are and what just happened. It's the difference between a fleeting conversation and a persistent workflow. Next is the tool controller. Harnesses never let the model touch the file system or APIs directly. The controller mediates every side effect. It validates arguments, throttles requests, and blocks dangerous actions. It prevents prompt-injected disasters, like a model trying to download a production database, and keeps flaky APIs from derailing the entire workflow. Then we have memory management, which is now a miniature database problem. Smart harnesses distinguish between ephemeral task memory, like a scratchpad, and durable project memory stored in vector databases. The harness decides what to summarize, what to embed, and what to evict, managing the context window budget like a financial portfolio. Holding it all together is the dispatcher. This is the central loop that feeds the LLM the current state, parses the model's intent, and routes control to the right component. It turns a stochastic, probabilistic model into a predictable system. It is the conductor that ensures the orchestra plays the symphony correctly, even if one musician misses a note. This architecture brings us to the concept of vibe coding. It sounds like a joke, but it describes what every developer actually wants: to state an outcome and skip the boilerplate. With harnesses, vibe coding becomes viable. You vibe at the system boundary, telling the harness to migrate our monolith to a microservice, and the harness decomposes that vibe into hundreds of concrete, testable actions. The harness enforces loops of plan, act, and verify. It logs every step and routes failures back through debuggers. It doesn't trust a single LLM call. It builds a scaffold of tools and constraints that forces the model to work until the job is actually done. This is how we get to 99% code automation. Looking ahead to 2026, the LLM will look more like a kernel, while the harness behaves like the shell. The hardware of the mind has plateaued, but the software stack around it is just getting started. The next 10x improvement won't come from GPT-5. It will come from better harness design, smarter planning loops, and richer world models. Software teams that treat the model as a commodity and the harness as the product are the ones who will capture the value. Everyone else will just be calling an API and hoping for the best. Don't be the one hoping. Start architecting your scaffold today. Subscribe for more deep dives into the architecture of the future.